So we have two methods for simplifying a complex rational expression. And for each one, we have a circumstance where it's easy. Dividing is easy when the numerator and denominator are polynomials or single rational expressions, and we're not adding rational expressions in either one. Whereas multiplying the numerator and denominator by the same thing is easy when the least common multiple of the internal denominators is very simple. But what if we have something that looks like this? We look at that and our first reaction is, ick, right? We're definitely adding and subtracting rational expressions in both the numerator and the denominator, so dividing won't be easy. But our denominators here have no common factors, right? The least common multiple of the internal denominators is literally just all four of them multiplied together. Neither method seems particularly easy here. In a lot of ways, that's actually good news, because here's what it means. In this circumstance, we can just pick whatever method we like. So if we want to do this by dividing, first, we'll actually do the addition or subtraction in the numerator and denominator. So let's see, that'll give us these two denominators, well, nothing in common, so we just multiply them together. So we'll have x times x minus 3 over x plus 2 times x minus 3 minus x times x plus 2 over x plus 2 x minus 3. Putting that together, we'll have x squared minus 3x minus x squared plus 2x all over that common denominator. And when we do that subtraction, we just get negative 5x over x plus 2 times x minus 3. That's actually not too bad. What about in the denominator? We have 2x plus 1 over x plus 1 over x plus 4. So let's see. Again, the denominators we just have to multiply together because they have nothing in common. So we'll have 2x plus 1 times x plus 4 all over a common denominator plus 1 times x all over our common denominator. So we'll have so that first numerator is 2x squared plus 9x plus 4 plus the second numerator is just x all over x times x plus 4. Carrying out that addition in the numerator, that's what we get. Okay, so this was my numerator. And this was my denominator. For our entire complex fraction, then, we'll want to take the numerator divided by the denominator. So we'll have our numerator divided by our denominator. We rewrite that as multiplication. And now to carry out that multiplication, we might try to factor this quadratic here. But a little bit of examination will show us that this is prime. And so we're just going to be left with this rational expression. And if we've lived a good life, no one will make us multiply this out, and we can just leave it that way. Now, we will get the same result if we decide to multiply our numerator and denominator by that LCM. Remembering that our LCM is just the product of all of these denominators. That's what we'll multiply our numerator and denominator by. We might want to shortcut the step where we distribute, and we just have something that looks like this. Writing this step is probably the most unpleasant part of this whole problem. But now we have those canceling, and those canceling, and those canceling, and those canceling. Something that looks like that. Now, to make our lives simpler, we might want to go through our numerator and denominator and pull out any common factors before we do any multiplying. Right? So we might get something like that's a common factor, and that's a common factor, and that's a common factor in the numerator, and then this is a common factor, and this is a common factor in the denominator. And now this arithmetic that we still have to do should be looking familiar from the last time through. X minus 3 minus all of x plus 2, that's going to be negative 5. So our numerator will end up with negative 5 times x squared times x plus 4. This multiplication and addition in the denominator, that's the same thing that we did in the other method. So our denominator will just have x plus 2, x minus 3 times two x squared plus 10x plus 4, which we noticed before doesn't factor unless you count, pulling out the 2, which isn't going to be interesting to us here. So we got the same result either way. In this particular example, I think method 1 was probably easier. And that's mostly because we ended up having to make kind of a weird move at this step where we had the big complicated expressions in our numerator and denominator and didn't want to multiply them all out. So in this example, method 1 was probably easier. However, they were both kind of a pain. So we can just pick whichever method we like better and not worry too much about one being slightly easier or slightly harder than the other. When we have the circumstances where one method is clearly easier, we should pick that one. If neither method is clearly easier, we can pick whichever one we want. And as long as we work carefully and correctly, we'll always get the same answer.